Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, we're going to be looking at another episode of Keam Crash Course, and in this particular episode, we're going to be looking at some sample questions for physics. Now, in this particular episode, we're looking at some questions, how to solve them, and how to recognize questions and ways to solve them in detail. So let's start off with today's first question. In an AC generator, mechanical energy is converted into electrical energy by virtue of electrostatic induction, magnetic induction, electric induction, electromagnetic induction, mutual induction. Now, if you know this already, then you would know that the AC generator is based on electromagnetic induction. But suppose you wanted to eliminate the options out of here, then you can start off with all the 5 options. Option A is electrostatic induction. This involves electrostatic energy, so therefore that means it's used for charging static bodies. Like, for example, if you had a ball which is non-charged and another hair comb which is charged, and then you put it quite close to the ball which is not charged, then you can separate the charges. And then by conduction, you can remove one of the charges, whether positive or negative, so that the ball becomes charged. So this is how you charge by induction. So this isn't used in an AC generator, so option A is incorrect. What about option E, mutual induction? Well, in mutual induction, you have 2 coils. Electricity is passed through one coil, which produces a magnetic field. That magnetic field by induction produces electricity, and then it flows out the other coil. However, mutual induction is used in transformers where you need to step up or step down voltage, so mutual induction is useful in that scenario and not for generators. So option E is incorrect. What about option C, electric induction? Electric induction is used for creating heaters and irons, where you are passing electricity through a coil, and then it becomes hot, and then you use that heat for various purposes. So option C is incorrect. Option B, magnetic induction. This involves making magnets by rubbing magnets with another and so on. So therefore option B is incorrect. The correct answer is option B, electromagnetic induction. So here we use a magnetic field to produce electricity, which is how an AC generator works. So the magnetic field is generated by spinning a magnet in a coil of wire, and the change in magnetic flux creates electrical energy to flow through the coil. Now, the magnet can be rotated using various forms of energy, whether it's water or steam burned from coal, etc. So that's how electromagnetic induction helps an AC generator. So therefore, in an AC generator, option D, electromagnetic induction, is the process by which mechanical energy is converted into electrical energy. Next question. Choose the wrong statement. Now we have 5 statements here. Now the idea here is to find out the incorrect statement. Now for these cases, we need to check each of the statements and find out which one is correct and which one is incorrect. The incorrect statement would become the right answer. Now option A, electromagnetic waves travel at the speed of light. Now the speed of light is the speed at which a light ray travels, and basically light is considered as part of the electromagnetic spectrum. So therefore, all electromagnetic waves, irrespective of wavelength or frequency, travel at the speed of light. So therefore, option A is true, which makes it incorrect. Electromagnetic waves are transverse waves. Now, what does transverse mean? It means that the electric and magnetic field oscillation is perpendicular to the direction of movement. So in an electromagnetic wave, we have an electric component oscillation and a magnetic component oscillation. Now, when they're oscillating, they're perpendicular to the direction of travel. So suppose if this is the electric field, then the magnetic field will be parallel to the electric field. This is perpendicular. And the direction of propagation would be here. So as you can see, the electric field is perpendicular, and the magnetic field is also perpendicular to the direction of motion. So again, this statement is true, which makes the option incorrect. Option C, the ratio of the electric field to a magnetic field in an electromagnetic wave equals to the speed of light. So what that means is electric field over magnetic field gives us the speed of light. This is a proven theorem, so therefore option C is also incorrect. The reason why it's incorrect, the statement is true. Now, option D, electromagnetic waves carry both energy and momentum. Is this true? Well, if we look at the composition of electromagnetic waves, they've got electric fields and magnetic fields. So therefore, both of these together create what's called a non-zero energy density, which means that the density of energy present in an electromagnetic wave is not equal to zero. Even though both fields are present, it's not clashed to form zero. So therefore, because of this, there will be energy and momentum in an electromagnetic wave. So the statement here is true again, which makes the option false. Now, by elimination, it's clear that option E is the correct answer, but we need to know whether this is false. Electromagnetic waves can be deflected by magnetic fields. This statement here is false. Electromagnetic waves are created by magnetic fields, but they cannot be deflected. Now, suppose for the sake of argument that this was the case, then a compass should deflect light because it's a magnetic object and it generates a magnetic field. However, there is no deflection because of a magnetic field. So therefore, option E is a false statement. And since we're asked to find out the false or the wrong statement, option E becomes the correct option. Now let's look at the final question for this episode. This is a match type question. We need to find out the incorrect match among the following. So we have 5 objects made up of semiconductors and their characteristics on the other side. So let's look at each of the options. Option A is transistor, and the statement given is that it switches in saturation state. Well, a transistor is made out of multiple NPN junctions. So basically, it's made out of semiconductors, some of which are negative and some of which are positive. And so because of this construction, it has a saturation state that makes for the on switch. If a transistor is saturated, whether with a positive or negative junction, it turns into the on switch, and that allows current to pass through. So therefore, the match is correct, which makes the option incorrect. Now, when we look at option E, light emitting diode, this is what is the expansion for LED. Now, an LED is described as heavily doped, forward biased PN junction diode. And yes, every diode is a PN junction diode. And LEDs are in fact positively biased, and they're also heavily doped because they need to emit light. So therefore, option E is a true match. It's a correct match, which makes the option incorrect. Option D is solar cell. Now, in a solar cell, light hits the semiconductors, but there is no bias. Basically, in a solar cell, it is not connected to a battery or a voltage source. It acts as a voltage source because of the solar energy that's hitting it, and this is due to the fact that it exhibits the photoelectric effect. So solar cell is an unbiased photodiode, and it does not need to be charged. So therefore, option D is also a true match. It's a correct match, which makes the option incorrect. Option C is Zener diode. Now, the Zener diode is a device used for voltage regulation. Now, the diode itself is reverse biased, but in order to make sure that it regulates voltage, it is heavily doped. So therefore, option C is a true statement. It's a true match, which makes the option incorrect. The option that is correct among the following, the incorrect match, is option B. Photodiode is incorrectly matched with forward biased p-n junction diode. Now, a photodiode is used as a light sensor. So to be used as a light sensor, the light needs to hit the diode, and then that changes the bias to forward bias, because the photodiode is placed in reverse bias. Now, photodiode is placed in reverse bias, so therefore the statement that calls it as a forward bias p-n junction diode is incorrect. Option B is the correct option, because we're asked to identify the incorrect match, and the incorrect match among the following is photodiode being called out as a forward bias p-n junction diode. So that concludes this episode of Keam Crash Course. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. If you did like the video, don't forget to share it with others, and also hit the bell icon below to get updates about our latest content. Also, don't forget to subscribe so as to be a member of this education community. So, until the next episode, take care, stay alert, bye-bye for now.